Now we're going to prove triangles congruent by ASA and AAS. This essential question looks like how are triangles proven congruent, only now we're going to focus on some additional theorems. Why are these triangles congruent? Notice the notation here shows we've got angles Z and X congruent, we've got angles V and Y congruent. We know based on vertical angles, this angle and this angle are congruent. So we have three congruent angles. Do we want the angle, angle, angle congruence? It's kind of a trick question, don't fall for it. There is no such thing. These triangles are not necessarily congruent. Angle, angle, angle is not enough for congruence. Okay, now these two triangles are definitely congruent. Let's figure out why. Not only do we have notation showing two angle pairs congruent, but they share this side Ki. So what's the order of the notation? We have an angle followed by a side followed by a second angle. So it looks like angle, side, angle. That's all we need. How about these two triangles? Why are these congruent? Well, all we know about them from the diagram is we have these corner angles congruent. We've got a right angle XVY is a right angle. Well, based on perpendicularity, that means XVW is also a right angle. That gives us two congruent angles so far. And then the segment VX is shared. So we have an angle followed by an angle followed by a side, which is all we need. Alright, let's do a formal two-column proof. In the diagram, you can see the notation angles P and T are congruent, angles Q and S are congruent. W is the midpoint of QS, that base of this diagram. Let's prove these two triangles congruent. Always start with what's given. Now, QW being congruent to segment SW is based on the definition of the midpoint and is the only additional information we need, because we already have two angles congruent, so the triangles are proved by angle, angle, side. Okay, parallel lines, AD and EC are parallel, and we are also given that segment BD and BC are congruent. Well, parallel lines, you can see, these are going to be cut by transversals. The parallel lines and transversals should immediately make you think of angle congruence, alternate interior angles, corresponding angles, alternate exterior angles. These are all congruent angles based on parallel lines. So when we're trying to build triangle congruence and you have parallel lines, think along those lines. So start with what's given. Now here we go. This is the angle D is congruent to angle C. How do we know that? So angle D and angle C, those are congruent because here's your transversal that cuts the parallel lines. Here's one parallel line, here's the other, as best as I can draw them. There we go. And these two angles here are on either side of the transversal inside the parallel lines, which is exactly what we're looking for, alternate interior angles. And actually A and E are in the same situation, only the transversal is this segment AE. There's your transversal, and the angles are alternate on either side of that transversal. Alright, so we've got a couple segments that are congruent. We now have two pairs of congruent angles. That's all we need for angle, angle, side. Okay, if we can keep our triangle straight in this diagram, I think we'll be on our way to a pretty simple proof. BC, segment BC, is congruent to DE. So that's this segment and this segment. AB is congruent to AE, so these two outside segments, and then angle B is congruent to angle E. Okay. So now we want to prove which two triangles. Let's draw them so we know what we're looking for. ABD is the first triangle. We want this triangle to be proven congruent to triangle AEC. So they're overlapping triangles, you can see. These two outside triangles, we actually have enough information to prove these two outside triangles are congruent based on side angle side, but because we've got this shared sort of inner part that goes with both triangles right here, both the red and the blue triangle, we've got to worry about this segment CD on the bottom. So let's look at this proof. Always start with what's given. Now here's the part that completes the proof for us. Why is segment BD congruent to segment CE, which is right here? Why are those two segments congruent? Well, think of segment CE as, actually I'll write it like this. Segment CE is actually CD plus DE, isn't it? It's this part, CD plus DE. Well, likewise, segment BD is actually BC plus CD. It's this, BC plus CD. Well, both of these segments share a CD, segment CD. So we're actually showing congruence here. Their measures are equal. If we cancel out CD, we've got BC equal to DE, and that's a statement that's given to us. BC is congruent, segment BC congruent to DE. So therefore we can also conclude what's in the proof, and that's segment addition postulate. That's all we need for side angle side to prove the triangle's congruent. Okay, here's a similar scenario, but a little bit more complicated setup based on what's given. We've got these exterior angles 1 and 2 congruent. We've got segment BD congruent to, so here's segment BD right here. Segment BD is congruent to segment CE. So we're actually starting with this as our given. And angle ACB congruent to angle ADE. So this angle congruent to this angle. We're proving triangle ACB. Do that in red. ACB. So now we're proving these little outside triangles are congruent ADE. That's what we're looking for, these outside triangles. Okay, we're given the overlapping parts are congruent down at the bottom. Now we want the outside. So it's almost the inverse of our last example there. Starting with what's given, things are a little bit more complicated because we're given congruence as the exterior angles 1 and 2, but we know the angles ABC and angles AED, those corner angles of the big triangle, are supplementary to angles 1 and 2, and that's the linear pair postulate. Well, if angles 1 and 2 are congruent based on what's given, A, B, and C is supplemental to angle 1, angle AED supplemental to angle 2, and those two angles must be congruent based on congruent supplements theorem. So that gets us then enough information there to show the angles are congruent. BC is congruent to DE. Now, just like we saw in the previous problem, being segment addition postulate, this is the segment subtraction postulate. We can cancel out the CD in both of those segments that are given to be congruent, and now we're set to show the angles, triangles congruent by angle side angle.